In the prior segments, we covered SQL for modifying database content. In this and the following segments, we'll look at changing the underlying database structure, modifying column definitions, adding and removing columns, modifying constraints, even refactoring entire tables. As with prior segments, we'll start with a fresh load of courses1.sql, so please do that now before beginning. Now, one common structural modification is to change the type or name of a column. For instance, what if our student teacher Josette Slingland here in the person table decides to take a hyphenated last name, Slingland-Henderson, we'll say. So there's our update to do that. And as you can see, we have a little problem here. We get an error for insufficient room because the last name column is only a varchar 15. As you can see from this create table statement that we had used originally to create the person. Now, lengthening a varchar column is a common requirement in database maintenance. To do this, and a wide variety of other structural modifications, we use the alter table statement. And this statement has several dozen different forms. To lengthen our last name column, we would use alter table person modify column last name varchar 30. Now, all alter table statements begin with alter table, followed by the name of the table to alter. This in turn is followed by one or two specific keywords like modify column, and then by details on the operation to perform. For modify column, we add the name of an existing column, last name, and the new declaration for it. So the example statement here thus redeclares last name in table person as a varchar 30, doubling the available room for it. So run this command on your setup, as I will here. And then let's do a select star on person just to confirm something here. The data is not changed. But if we run the update for Slingland's name, then it works without trouble. And we can repeat the select star to see the update right there. Now, by the way, some alter table keywords can be dropped if their omission doesn't cause ambiguity. Since last name is clearly a column, the command alter table person modify last name without column itself would also have worked. So from now on, we'll use this shortened form of the alter table modify command. Now, under MySQL, the easiest way to verify a structural change to a table is the MySQL, it's not a SQL standard, show create table, and then the table name, in this case person, statement. So if we run show create table person, we get a printout of a create table statement that would create the person table as it presently is, complete with column declarations. It's not a perfect duplicate of the create table statement that you would run, since it includes some redundancies. For instance, it shows default values of null for nullable columns that don't have any other default. That is accurate. Null is the automatic default, but it's redundant. Also, show create table sometimes shows extra keys and constraints added automatically by MySQL. Nonetheless, its output is a runnable create table statement, and it lets you verify table structure changes. And you can see from its output that last name is now varchar 30. Now, the alter table modify statement does more than just lengthen varchars. It lets you change a column to any new column type, as well as add new not null or default conditions. And this opens the question of what happens to existing data when the column type changes more radically than just becoming a longer varchar. For instance, lengthening a varchar obviously won't disrupt the existing data, but what about shortening the varchar to a length below that of the longest data currently in the column? Let's explore this briefly with a small sequence of in-lecture questions. And part of the intent here is to get you used to alter table statements, so be sure to actually run each of these tests, even though they're pretty simple questions. So, question 1. Try shortening first name to varchar 5. And what happens if you do that? Coming back from a pause there. You needed to run alter table person modify first name varchar 5, and the change is rejected for the obvious reason. It would lose information. We have data that's longer than 5 characters. In general, column modification that would lose information gets rejected. But that doesn't mean you can't make some pretty radical changes. Question 2, try changing units completed, which is currently an int, of course, to a varchar 3. What happens if you do that? Does it permit the change, and what happens to the data if so? Coming back from a pause here. What you needed to run is alter table person modify units completed varchar 3. And it's just fine doing that. So let's do a show create table and make sure that it actually did change. And yeah, there's the units completed with this varchar 3. So now I'm interested in what the content looks like. Select star from person. And the units completed is all there. But evidently what they are now are strings, not integers. So SQL won't allow a column redeclaration that loses information, but it's perfectly happy to change the format of the existing data. Converting the existing units completed integers to textual string equivalents still preserves the essential information, and it would, in principle, allow them all to be converted back to their original int form. So question 3. Now change units completed back to the original int 11. Does that work too? And while we're at it, try changing major to a not null column with no other change. Leave it as a varchar 30. Is that okay? Coming back from a pause there. The units completed conversion should be fine. Alter table person modify units completed int 11, and we're good. The string numbers were converted back to normal integers, of course. Now, to change to not null for that major column, we need alter table person modify major varchar 30 not null. That one is not going to go through. And it's rejected because there are some null values already in the column. And we couldn't keep them without violating this new not null restriction. Also note we needed to repeat the varchar 30 when trying to add not null to major. The new column type must be a complete declaration, even if that means repeating some parts that aren't changing. So in general, SQL will allow any column type change, even a radical one, as long as there's a reasonable, no-loss way to convert the existing data without violating the rules of the new column type. Otherwise, it rejects the change. Okay, let's try a few more interesting variations. Does running alter table person modify gender char 1 have any effect at all on the gender column? And there's the statement there. Does that affect the gender column at all? Coming back from a pause, executing it doesn't seem to cause complaint, but yeah, it does affect the column because the gender column is no longer not null. It drops the null characteristic. Now again, unless not null and other modifiers like default are repeated in the alter table modify command, they get dropped. As we just said a moment ago, you must give an entire column declaration, including repeating any parts you want to keep. Okay, now let's change person.id here to varchar 3 from its current integer type. You can drop the auto increment too, since that applies only to integers. All the existing IDs are at most 2 digits, so this should work as well as the change of units completed to varchar 3 did. Is that so? Does it? And why or why not? Back from a pause, the command you should have entered would be alter table person modify id varchar 3, and it's rejected. And the reason it's rejected is because it's used by an index in a foreign key constraint of table courses.takes. So it's actually in a foreign key in another table, and you can't modify a column type that would be used in a foreign key because all the key values in the foreign key would need to change as well. Even if ID were not used by a foreign key, the change would still be rejected because ID is also the primary key and is thus used in an index. If you want to change a column type that participates in an index, you must first drop the index, then change the column type, and then recreate the index, so the new index can be built from the converted column values. So we'll look at adding and dropping keys or indexes shortly here. And first let's do question 6. As always, please look up a good reference page, like the MySQL manual, which has one, for alter table syntax, and find out how to change a column's name and its position within the table. Use what you find to rename the dept column here in person to department and move it so that it falls after gender in a show columns or a select star listing here, or in the create table listing. You'll find that you need a different alter table form than the modify one we've been using, though it's closely related and similar in form. And again, part of the agenda is just to get you exposed to the various alter table forms. So coming back from a pause there, and hopefully some research, what you should have come up with is something like alter table person change, and this is change or change column, either one, change department, DPT, to department. So you have in the change, not modify, version of alter table, the opportunity to take an existing column, change it to a new name and a new type. And then you may also add after and some existing column, and it will put the new column after that in the sequence of columns in create table or select star listings. And a show create table person will illustrate what I mean there, with department now appearing after gender. And here's one final interesting point. If you run alter table person change ID to ident int 10 auto increment, you'll find that it works, despite what we said in answer 5 about modifying columns that participate in foreign keys or indexes. Why would that statement work, while the one in question 5 is rejected? Think carefully about the impact on the foreign key of the two different statements. Coming back from a pause there, well, changing the ID column to varchar3, as we did in question 5, completely changes the format and storage of key values in the foreign key and the primary key. But a change of column name doesn't affect the key values themselves, just the name you use to refer to the column. Neither does a change from int 11 to int 10 have any big impact. Recall that the parenthesized values are just glorified format specifiers that don't change the underlying type. So you are allowed to change an index participating column as long as you don't do so in ways that disrupt the underlying key values. Now, in the next segment, we'll look at adding and dropping columns and changing constraints.